So in this problem, we have some sort of square box that is 1,400 newtons in its weight. And it's being pushed along, and sorry, I forgot to draw this up here, but this should be 5 meters as well. We first want to find respectively, so not at the same time, but what is the force, or what is the work required to move this 1,400 Newton box 5 meters in the x direction and 5 meters in the y direction. So we're lifting the box and we are moving the box. We're also given that the force of friction is 270 newtons, so that's going to help us. Hopefully this problem doesn't come across as too difficult, but if it's your first time approaching some of these problems, it might be a little tricky. So we first have to define what work is. So work is equal to a perpendicular force in the same way that you're moving times the distance of which you traveled. So work here, we know that the distance is equal to 5 meters. And we're going to start with x. Let's start with x. We need to move 5 meters in the x direction. Okay? So we have distance. Do we know what the parallel force is? Well, we assume that the minimum force we need is 270 newtons. Let's assume perfect efficiency. We are perfectly moving it at 270 newtons, 0.00000 infinity 1. Okay? So it's just enough to get that box accelerating, and we overcome the static friction, right? So let me just write this out here quick. So we have 5 meters. So we need an equal and opposite force to overcome that friction. That is 270 newtons. Well, there it's just a plug and chug, right? Work is equal to 270 newtons times the distance, 5 meters, and notice the units, Newton meters, that's a joule, okay? A joule is a Newton meter. So the work done in the x direction is equal to 270 times 5, which is 1.35. Can I do that? Yeah, I can do that. What am I saying? Yes, I can do that. Yes, I can. Kilojoules. I just converted it. You would get a Newton meter, which would be just joules, or you could say this is 1,350 Newton meters. Either 3 of the answers are fine. We can use the same idea for lifting the box. Well, we know that the box sitting on the floor, it has a weight of, or it's always going to have a weight because it's just mass times gravity, of 1,400 newtons. Okay? So that's actually our parallel force, right? We were fighting friction in the x direction, now we're fighting its own weight. So we need just above 1,400 newtons to lift that box up in any respectable amount. And it's going to take, we need to travel distance of 5 meters. So how many joules of energy do we need? Well, we need to combat a force, and we're trying to move the box that way. The parallel force is that way, so 1,400 newtons times 5 meters. And that will give you, for the work in the y direction this time, times 5, that should be 7,000 joules, 7 kilojoules, or 7,000 Newton meters. You can express it either way, they're all equivalent. Hope you guys enjoyed. That was a very simple question. I have some other problems related to work on my channel, so feel free to check it out if you so please. Have a wonderful day.